Hello everyone! Today we're going to talk about some more Algebra 1 topics. Today we're going to talk about writing equations. So we have one and only one goal for the day, and that is to translate equations into verbal sentences, and then vice versa. We're going to go from verbal sentences into equations. Alright, and today I have a bit of clip art. And this came from Wikipedia, so thank you Wikipedia for this image. And anybody know what this image is? If you said the Statue of Liberty, you are correct. So we're going to look at a problem with the Statue of Liberty, okay? So let's go ahead and write this out. So the Statue of Liberty sits on a pedestal. That is 154 feet high. Okay, the height of the pedestal and statue is 305 feet. Alright, now we want to know if S represents the height of the statue, then what equation represents the situation? Alright, great question. Alright, so let's break this up. So we have the height of the pedestal. Okay. And then we have the total height of everything. Okay. And we know that the height of the pedestal is 154 feet. And the height of the pedestal plus the statue is 305 feet. Okay, so let's write this into an equation. So if we have 154 feet plus, and we're going to make this part S in feet. Okay, because they say if the S represents the height of the statue plus S in feet, this equals 305 feet, right? Because if you take the height of the pedestal plus the height of the statue, that's the total height, 305 feet. So let's go ahead and solve this while we're at it. So if we subtract 154 feet from each side of the equation, we get that S is equal to 151 feet. Pretty tall statue. But did you know there are other statues in the world that are taller than the Statue of Liberty? And if you know what they are, I'd like for you to comment and let me know. Okay, so let's look at some examples here. Alright, so let's look at example 1. We want to translate each sentence into an equation. Okay? And let's start with A. We have 1 times the number x is equal to 3 times the sum of y and z. Alright, so let's go through here and dissect this verbal sentence or written sentence. So we have 1 times, that's like 1 times, but instead of a times, let's put a dot. Okay? 1 times x is equal to 3 times the sum of y and z. So we should say y plus z. So let's go ahead and rewrite this. So 1 times x is just x. So x is equal to 3y plus z. Alright. Great job. Let's do another one. We have 7 times a subtracted 7 times a subtracted from 12 equals 40. Okay, so this is written in a strange way where something is subtracted from something else. So you have to put the other number first before you subtract the first number. So we're going to say this is 12 minus 7 times a, which is equal to 40. Okay? So what we did here is we put this 12, since it's from 12, we put that at the beginning. Okay? And then we subtracted 7 times a. And then we set that equal to 40. Alright, let's talk about a plan. It's always good to have a plan. Does anybody have any plans out there? Let's talk about a 4-step plan. And this is for problem solving. Okay? So let's talk about step number 1. Ooh. Screen jumped on me there. Okay. Step number 1. We want to explore the problem. We want to read through it and kind of figure out what is it really saying. Then 2, we want to plan the solution. Okay? And 3, so what we're going to do is come up with a plan of how to solve it. Now 3, what we're going to do is we are actually going to solve the problem. I like this. I like solving problems. And then number 4 step, we are going to examine the solution. Okay? So we're going to find out what the problem's really saying. Then we come up with some kind of plan of how to solve it. Then we execute, we solve the problem. Then we want to look at the results and say, does this make sense? Have a bit of a sanity check, if you might say. So let's look at a problem. Let's look at an example here. Example 2. All right. In how many days can the analyst solve 4 analyses? So we want to know how many days does it take for this analyst to do 4 problems. Okay, so let's explore. What do we know? This is step 1, right? Explore. Well, something we know is we know that the analyst can solve 3 analyses per day. Okay, so if we know he can do 3 in a day and we have 4, right? So let's come up with a plan. Okay, so we need to write an equation for this. And so we know that if we make x the number of days, we can find that he does 3 of these per day, but there's a total of 4. Okay? Now, the next thing is to solve the equation. So if we take 3x is equal to 4 divided by 3 on both sides, then that gives us x is equal to 4/3, which is equal to 1 1/3 days. So we solved it. Now let's do the next step. We want to examine the results. See if this makes sense. So if we take 4 times 1/3, so we have 4 analyses and it takes 1/3 of a day to do 1. We know then that that is 4/3, which equals 1 1/3. So I think it checks out. I think our results make sense. What do you think? All right, let's look at a definition. We have the word formula. This isn't the stuff that we're talking about babies eating. This is something else. We're doing math here, okay? This is not baby formula, but we're going to take baby steps and explain all this. Okay, so this is an equation that states a rule for the relationship, and sorry if you hear baby number 3, between certain quantities. Okay, so this kind of just shows how different quantities are related through an equation. Equation has equal sign, right? So let's look at an example. Example 4. So the perimeter of a rectangle equals 2, let's try again, 2 times the length plus 2 times the width. Alright, let's draw our old-fashioned rectangle. So we got length and we got width. And we'll say that perimeter is P. And that goes all the way around the rectangle, around the outside edges. Okay, so what is this equation? P, the perimeter, is equal to 2 times the length plus 2 times the width. It's that simple. Great job. So this is the formula for perimeter of a rectangle. All right, let's look at another example. I think that was maybe example 3, and I think I wrote example 4. So let me clarify that. It's getting ahead of myself. All right, now we're going to look at example 4. Just in case you have comments or questions, we're referencing the correct equation or example. All right, let's look at A here. We have x plus 3 equals 7. Wow. Okay. So what we want to do is we want to write this from an equation to a sentence. Okay. So what we're going to do is say that x plus 3 is equal to 7. Great job. All right, let's look at another one here. Let's have x plus y is equal to z squared. Okay? The sum of x and y is equal to the square of z, right? Let's go back and dissect these. So we got x plus 3 is equal to 7. Okay? Let's dissect this one. The sum of x and y is equal to z squared, the square of z. Okay? Alright, let's solve some problems here. We like solving problems. Alright, let's say that we have one about the Earth. That's where we live. And let's talk about the Pacific Ocean. Has anybody seen the Pacific Ocean before? If you have, you're welcome to comment. I'd like to hear about when you saw the Pacific Ocean. Alright, so the Pacific Ocean covers 40% of Earth. Okay? And let's say if P represents the area of the Pacific Ocean, and E represents the area of the Earth, we want to write an equation for this situation. Okay, so I gave a lot of information there written in white, and then what we need to do, I wrote in red. So we have the Pacific Ocean. It takes up 40% of the Earth, 46% of the Earth. And that's going to be called P. And then we have E, which is the entire Earth, 100% of the Earth. Okay? So P is only part of E, because E is the entire Earth, and P is part of the Earth. And how much of it is it? It's 40%, 6% of the entire Earth. Okay? So let's write this out. We have P, that's going to be equal to 46% of E. Or if we write this in decimal, 0.46 E. Okay? Because P is only 0.46 of E. E is bigger than P. Okay? Because P is only 46% of E. Alright, let's look at another problem. Let's say in a right triangle, the square of the measure of the hypotenuse C is equal to the sum of the squares of the measures of the legs the legs A and B. Alright, let's draw this triangle. So what is a right triangle? Let's draw as best as we can a right triangle. So a right triangle has a 90-degree angle here. So we draw that by drawing the box. This is 90 degree. Okay? And let's say that this is length A and this is length B. And this is length C. This is the hypotenuse. It is the longest part of the triangle. So C is longer than A and B. Okay? So let's write an equation for this. So we're looking at the square of C. So if we do C squared, right, the square of C is equal to, all right, so we got the equal sign, the sum of the squares of A and B. Okay, so we got to add together the squares of A and the squares of B. So A squared plus B squared. This is a very famous theorem, Pythagorean theorem. And if you haven't learned this already, it is very handy. We use this a lot in my field, a whole lot. It's unbelievable how much we use this. It's a very handy tool, and when you know one bit of information, like maybe you know the length of A, and you know B, then you can get C. Or if you know C and A, then you can get B. Or if you have A and let's see. I can't erase. All right. Say you have C and B, then you can get A. Okay. So it's very, very handy. And what you can do, say you know A and B, but you don't know C, then what you can do is C is equal to the square root of A squared plus B squared, because you have to take the square root of both sides. Okay? And then that's how you solve for it. It's really, really nice equation. I really have a lot of appreciation for this, and if you have any questions about it, I'll be glad to answer it. Alright, let's move on with another problem. And this is another one that I use every single day. So the temperature I can write the temperature in degrees Fahrenheit is the same as 9/5 of the degree Celsius. Don't know if that's British or American English. My notes have spelled this way. C plus $32. Okay, it's a terrible looking 3. 32. All right, so let's find what we're looking at. So we're looking at degree Fahrenheit is the same as. So same as is kind of like equal to. Okay, 9/5 of degree C plus 32. So let's write this out. So the first thing is we have Fahrenheit. Okay, degrees Fahrenheit, that's equal to 9/5 C. 9/5 degrees C plus 32. Oh man, that's really great. Really great. So let's look at if we have the answer in Celsius, we can get to Fahrenheit. Let's look at how this would look if we have Fahrenheit but we're trying to get to Celsius. So we would need to subtract 32 from each side, and we need to multiply each side by 5/9. Okay? So if we have degree Fahrenheit minus 32 all times 5/9, that's equal to degree C. Really phenomenal, right? Yes, yes, very phenomenal. Okay, well, that's all we had today. And if you have any questions, let me know, and I'll do my best to answer them. And if you haven't already subscribed to the channel, please do so, and click like if you like the video. I will see you all next time. This has been MultiPro.